We're going to be looking at today what we call our linear functions. We've been looking at functions, and so we're going to look at linear functions, which will graph to be lines, and we're going to look at the slopes of our linear function. Now, slope can be defined in several different ways. It's a ratio, and so it's a ratio of what we often call rise, how much we've gone up, to run, how much we've gone horizontally. And that's an easy way to remember it in words as to what we mean by slope. And so often if you'll just remember, well, it's rise over run, then you'll know that your rise is going up and down and your run is going horizontally, or rise is vertical. And so we're also going to define it that way, that it's a vertical change It's the vertical change over the horizontal change. And if we're talking about a vertical change, then we can talk about the change in y's. And often we'll use a little triangle to mean change. And so the change in y's, because your vertical axis is your y-axis, over your change in x's. And so you can also word it that way, the change in y's over the change in x's. Now, if you're talking about a change, then you figure out how much something has changed by subtraction. So we can give it a formula that it's y sub 1 or y sub 2. It doesn't matter. All the subscript is there for is to show that it's a different y. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now that is important, that this y and this x come from the same ordered pair. This y and this x come from the same ordered pair. It doesn't matter which one you call y sub 1 and which one you call y sub 2, but once you've determined which one's your y sub 2, then that x that goes with it has to be your x sub 2. And this is what we call slope. Now for slope we use the letter M, and most likely there's a French word, monter, and it means to rise or to ascend. And I think we've got our word mountain came from the same word, or it's a derivative of that. And Descartes, who was French, is the one that did our analytical geometry. So we use an M, and so think of that as a mountain, and a mountain goes up. And so this is what we're talking about with slope, is how much we've gone up compared to how much we've gone horizontally. And so if you want to do it in just symbols, it's how much we've gone up or down. Now we can talk about going right or left. I always go to the right because we read our graphs left to right. And so we'll take care of our positive or negative by going up, and then we'll take care of our horizontal by going to the right. Now let's look at how we can use this formula. If we have, let's say we have the 2 points, negative 3, 4, and negative 4, negative 2. Okay, if we want to use our formula, we can designate one of these as the sub 1s and one is the sub 2s. And again, it doesn't matter. So I'm just going to call this one the y sub 2. So this is my x sub 2. So this would be x sub 1, y sub 1. So we're going to have 4 minus a negative 2 divided by negative 3 minus a negative 4. Now we know from our sign rules that minus a negative is the same as a plus, so this would be 4 plus 2 over negative 3 plus 4, which will give us 6 over 1 or 6. What that means is for every 6 units we go up, since it's positive, then we'll go 1 unit to the right. If we wanted to graph those 2 points just to see what's happening, we have -3, 4, and -4, -2. And to get from one point to the other, oops, then you can see to get from this point, we've had to go up 1, 2, 3, 4, 5, 6 units, and to the right 1. So our slope then is in the ratio of 6 units to 1, or 6. We have a slope of 6. Okay, let's look at another one. The slope formula is a very important formula. It's one that you need to memorize. So let's take the points negative uh, or positive 4, -2, and the point -1, 5. So again, we can call these our sub-2's. And for the first few times that you do this, you may need to label them. You've probably done slope a lot, and so it may not be necessary for you to label them. But we have -2 minus 5, the change in the y's, over the change in the x's. 4 minus a -1. And I always say that this is a minus, and then I put down what my other number is. If I need to go back and change my signs, I do. And I know that minus and negative's a plus. So that gives me -7 over 5. And we're going to leave it this way. Now, that's a -7/5 is what the slope is. But don't change this to a mixed number, and don't change this to a decimal. So since our slope was negative, that meant we went down 7 units for every 5 units we went to the right. If you have a positive slope, your graph will be going up as you go to the right. So if your slope is positive, you're going to be going up as you go to the right. If your slope is negative, your graph will be going down as you go to the right. And we're going to look, if your slope is 0, you're going to have a horizontal line. If your slope is undefined, you're going to have a vertical line. Now, those are things that you need to know just as you look. With a positive slope, your graph, and we always read them left to right, is going up as you go to the right. If you have a negative slope, your graph is going down as you go to the right. If you have a slope of 0, then that means you have a horizontal line. Doesn't matter how many you're going up, you're always going, it's going to be 0 is how many you're going up, and then it doesn't matter how many you go to the right. And for a vertical line, our slope is undefined because we have a rise, but our run is 0. And you cannot divide by 0, so we say that our slope is undefined. And let's just look at a couple of those with the 0 and the undefined so that you can see how that happens. Let's say that we have the points 2, 4, and the point 2, -3. Okay, if we do our slope, then it's the change in the y's, so 4 minus a -3 over the change in the x's, 2 minus 2, which minus a negative gives us a plus, and so that will give us 7 over 0. Well, that's undefined. If we graph that point, or those 2 points, then we would have 2, 4, Don't know why I keep losing this. We would have 2, 4, and 2, -3. So you can see we would have a vertical line. If we had the points 4, 2, and -3, 2. Well, as we do our formula, it's the change in the y's over the change in the x's. So that gives us 0 over 7, which is 0. You can divide 0, you just can't divide by 0. If we graphed those lines, those points, we have 4, 2, and -3, 2. And you can see that we have a horizontal line. So you need to remember that horizontal lines have a slope of 0, vertical lines have a slope that's undefined. Okay, once we do this, then we want to be able to write an equation given 2 points or given a point and a slope, given different information. So we're going to look to see how we would come up with an equation for that. Let's say that we have a graph. And we have 2 points on it. And let's call this x sub 1, y sub 1. And just to point any place else, it doesn't really matter. And this one we'll call x sub 2, y sub 2. Okay, now we're going to go back and change that. I'm sorry. Didn't mean to do these as sub 2's. We have a point someplace else. It's not a particular point. It's just a point. And so we're just going to call it xy. Simply because we don't want to deal with that we're having to have a certain point. So let's go through and we'll make these our sub 1's. Now, if we did our slope formula between those 2 points, we would say that the slope is equal to the change in the y's. And I'm going to start with the y that I don't know. This is the y I do know. So y minus the given y over x minus the given x. It's the change in the y's over the change in the x's. And in this case, we're given one of ours. We don't know the other one. We don't know where it is, but we know that the slope between those 2 points would be the change in the y's over the change in the x's. Now, if I treat this as a ratio and I do my cross product, some of you may need to put this over 1, most of you probably don't. We would have that the slope times x minus the given x is equal to y minus the given y, whatever that y is. And I'm going to use my symmetric property and switch this around. And this formula is what we call our point slope formula. Now, what we're given here, and that's why I went back and changed that I did not know this x and y. I didn't know the x and y here, but I knew the slope between those 2 points. So I knew my slope, I knew one of my points, and now I'm going to try to find my other point. And so you know the slope, you know one of your points, and you're going to try to find that other point so that it would be the point that would give you that particular slope. So we call this the point slope formula. And it's a very important formula that we will work with quite often. If you know the slope and you know a point, then you're going to be able to write an equation and find any of your other points. And that's why we need the equation, is to find any other point on the graph. So let's look at how we would do this. Let's keep our formula here. And let's say that we knew that the slope was 6 and that it passes through the point -2, 5. We have a slope of 6 and a point of -2, 5. We're going to use our formula. And as I read this, how I read it is y minus the given y. So I know which y I'm substituting in my point for is equal to the slope times x minus the given x. So we would write this as y minus the given y is equal to the slope times x minus the given x. So we have y minus 5 is equal to, well, we know that minus a negative is the same as a plus, is equal to 6x plus 12. And now what we're going to do is to write this in what we call our slope-intercept form. Up here it's written in our point-slope form. And then we're going to look at what we mean by slope-intercept. So most of the time as functions we want to solve it for y. So we will add 5 to both sides and have y is equal to 6x plus 17. Now what we're going to call this form is our slope-intercept. And I'm going to show you how we come up with that's our slope-intercept. Now there may be times that you're asked to write it in point-slope form. This is writing it in point-slope form. Y minus 5 is equal to 6 times x plus 2. That would be point-slope form. This form is slope-intercept form. And let me just go ahead and show you where we come up with that and why we call it the slope-intercept form. When we get into graphing, then that's going to help us a lot is to have it in slope-intercept form. We're going to look at that just a little bit more later, but let's go ahead and see where that comes from right now. If I have a graph and the point I'm given is a y-intercept, then the coordinates for that, my x value is 0, and I'm just going to call my y value b. It could be any number, but I'm going to call it b instead of calling it y because it's a special y. It's the y-intercept. And then I know the slope. So this is going to be my point, and I have some slope. So putting that into my my point-slope form, I have y minus the given y is equal to the slope times x minus the given x, which is y minus b is equal to mx, because m times 0 is 0. Then if I solve this for y, I would add b to both sides, and this is what I call my slope-intercept form. I have my slope and I have my y-intercept. So if you know your y-intercept and your slope, you can go directly to the equation. If you don't, then you're going to have to go through the point-slope formula and to find that. So as you write your answers, sometimes you may be asked to write your answer in point-slope form. Most of the time, even though we use the point-slope formula to get the equation, we're going to want our final answer written in slope-intercept form. So you may want to practice doing both. Let's take another point, and if we have a slope of -2/3, and it passes through the point 6, -2. Okay, we have a point, we have a slope, so we're going to use our point-slope formula. Y minus the given y is equal to the slope times x minus the given x. Okay, we know that minus a negative is the same as a plus, so I'm going to rewrite it with a plus. And here I need to distribute. So I have -2/3 times x. Then I have a -2/3 times a -6, so that's going to be a positive. Okay, 2/3 times 6. We're going to be able to cancel, but if you need to go off to the side and do your multiplication, that's okay. 3 goes into 6 2 times, and 2 times 2 is 4. Now, up here is our answer in point-slope form, and you would probably rewrite that as plus 2. But let's write our final answer in slope-intercept form also, which is usually the better form, and it's a more common form. So we end up with y is equal to negative 2/3 x plus 2. So what we know, and we'll look at graphing them a little bit more later, that's kind of not a very straight line, but our intercept's at 2, then we have a slope of negative 2/3, which means we go down 2 to the right 3, down 2 to the right 3, and we're going to be able then to draw our line. We know immediately, since our slope's negative, that our line is going down as we go to the right. You're not always going to be given the slope and point. You may be given 2 points. Let's say we're given the points 3, 5 and 8, 15. Well, to be able to write an equation, you have to know the slope. We can't write an equation without knowing the slope. So we have 2 points, so we know how to find the slope. It's the change in the y's, and it doesn't matter which ones you use. I'm just going to go ahead and do this 5 minus 15. Since I did use this as my first y, I have to use this as my first x. That's the only important thing. So I end up with negative 10 over negative 5, which is a positive 2. So I know my graph's going to be going up as I go to the right because I have a positive slope. Now I have the slope and I have a point. I have 2 points, but all I need is one of them. So you just pick one. It doesn't matter which one you pick. I'm going to pick this one. So we have y minus the given y is equal to the slope times x minus the given x. And in point-slope form, that would be our answer. If we want our answer in slope-intercept form, then we would have y minus 5 is equal to 2x minus 6, and then adding 5 to both sides, 2x minus 1. And we would have our equation in slope-intercept form. This would be point-slope form. This is slope-intercept form. And this is actually the more useful form is graphing. There are some other things that we would do with this form, and so it's important that you know it, but we usually want our final answer in slope-intercept. Let's say we have the points negative 3, 6, and 3, negative 2. Well, again, we have to have the slope, so we're going to use our formula. 6 minus a negative 2 over negative 3 minus 3. Well, that's going to give us a positive 8 because minus a negative is the same as a plus over negative 6, which reduces to negative 4/3. Do not change these to mixed numbers. Do not change them to decimals. Now, we've got a slope. We have a point. It doesn't matter which point we pick. I'm just going to pick this one. So we would have y minus the given y is equal to the slope times x minus the given x. So this would give us y plus 2. And I'm going to go ahead and put my equation in slope-intercept form. So I'm going to distribute negative 4/3 x, then a negative times a negative is a positive. 4/3 times 3 is 4. Those 3's will cancel, so it's a positive 4. Then I would subtract 2, so y is equal to negative 4/3 x plus 2. We could be told that we have a point that passes through or a line that passes through the point 2, 4, and it has an x-intercept of -2. Now we have to write the slope. To write the slope, we need 2 points. Well, remember your x-intercept is a point. And when we talked about our x-intercept earlier, I showed you writing it as a point, which is a little bit better in this case, as 2, 0. For the x-intercept, y is 0. And so let's write it as an ordered pair. Now we have 2 points, and so it's going to be a little bit easier. Our slope will be the change in the y's, so 4 minus 0, over the change in the x's. So we end up with 4 over 4, which is 1. We have a slope of 1. Now, we have the x-intercept, but we don't have a special equation for the x-intercept. So that slope-intercept form is only for the y-intercept. So we're going to have to use our point slope. So y minus the given y. Now I'm going to use this one because it's got a 0 with it. So it's y minus the given y is equal to the slope times x minus the given x. So we end up with y is equal to x plus 2. And so that would be our equation. If we had okay. Let's say that we have 2 points. For 1 and 3, 1. Okay, we have 2 points. Now, when we start doing this, we need our slope, so it's the change in the y's over the change in the x's, which is 0 over 1, or 0. We have a slope of 0. Now, what kind of line had a slope of 0? Well, a horizontal line. So horizontal lines only cross the y-axis. If you think of a horizontal line on our coordinate plane, then it only crosses the y-axis. So we can only have a y value. Well, notice in both of our points, our y value was 1. So we can come up with that our equation then is y equals 1. Now, if you forget that, we had a slope, so we can go back. Y minus the given y equals the slope times x minus the given x. So we have y minus 1 equals 0, because 0 times anything is 0, and y equals 1. So that would be what would happen when you had a slope of 0. Okay, we're going to look at the slope-intercept form, and we already talked about how that we got that slope-intercept form by using a point that was the y-intercept. But our slope-intercept form then is y equals mx plus b. M is our slope, and b is our y-intercept. And be sure that you know that that is the y-intercept. So we can use this then to graph. Let's say that we want to graph, and let's go to some graph paper here. Let's say that we want to graph y equals 3x minus 2. So we want to graph this. Well, the -2 is our y-intercept. So that means that's where we're crossing the y-axis, is here at -2. Now our slope is a +3. And if we wrote it back as a ratio, it's +3 over 1. That means from this point to get to the next point, we're going to go up 3 units, to the right 1. And the first few times that you do this, you may need to even go this, since it's a positive, we're going to be going up and to the right. I always go to the right if I can. Now, if I run out of room, then I might have to go back to the left. But I go up 3 to the right 1, up 3 to the right 1, and that gives me then my line. And so it's going to go through all of those points, and it is a line, and so it keeps on going forever. And so we would have then our line, and all of the line represents all of the points that would make that equation true. Uh, let's look at another one. Let's just clear this one, and let's say that we had y is equal to 2x plus 1. Okay, again, the 1 is my y-intercept, so that's positive 1. And I have a slope of 2, so I'm going to go up 2 to the right 1, up 2 to the right 1, and then I'll draw my line through those points, and I have the graph of my equation. If we wanted to graph say we want to graph y is equal to negative 2/3 x plus 3. Now in this, I left out my x. Okay, negative 2/3 x plus 3. So my y-intercept is 3. That's on my y-axis. Now I have a negative slope. What I usually do with a negative slope, then I go down. I deal with my positive and negative with my rise. If it's positive, I go up. If it's negative, I go down. My run, I always go to the right if possible. So this means I'm going to go down 2 and then to the right 3. That's going to give me a negative move. Going down is negative, right is positive. And so from this point, I'm going to go down 2 to the right 3. Down 2 to the right 3, and then I can draw my line through those points. And it's going to keep on going, but you have your line, and that gives you all of the points on that line. We looked at a line a while ago that was horizontal, and so let's look to see how we would graph that one. Let's say we had y equals 2. Now in all of these I've been putting y equals. We could also, because these are functions, we could also have this as f of x equals. So if you had an f of x equals something, that f of x is the same as your y. It is your range. The y is your range. So y equals 2 is a constant function. That means that our slope was 0, which we know then means we have a horizontal line. And we have a horizontal line through the place where y equals 2. So our line is going to be horizontal through the point where y equals 2. If we wanted to graph a vertical line, and I'm just going to do that on this same plane. Let's say we want to graph a vertical line of x equals 3. Now, vertical lines have a slope that's undefined. How I always remember this, if my equation only has an x, then I'm only going to cross the x-axis. If my equation only has a y, I'm only going to cross the y-axis. If my equation has both an x and a y, then I'm going to cross both. I'm going to have, I'll cross both axes. So if it has both an x and a y, then I'm going to cross both. So this one only has an x. So that means I'm only going to be crossing the x-axis. And I'm going to cross the x-axis at 3. So 3 is my x-intercept, and I'll cross my x-axis there, and I'll have my line where x equals 3. And I have a vertical line. So if you only have an x, you only cross the x-axis. If you only have a y, you only cross the y-axis. And vertical lines, our x equals 3 was not a function because it doesn't pass the vertical line test. Okay, we're going to also look at what we call the general form, but we're going to do that in the next lesson. And we're also then going to look at finding our graphing using our x and y intercepts.